As you know from our first video on microbiological instability and self-heating in soya beans, I'm Alexandra Hadjimichailoglu, a senior claims advisor at GARD, specializing in cargo claims. Today, we are doing our second video with the assistance of Dr. Moss of Brookes Bell. We will be learning about the different types of sweat experienced with a variety of cargoes, including soya beans, and how to ventilate appropriately. This is very useful information for any seafarer involved with this practice. Tim, can you tell us a bit about your background and why you get involved in sweat issues?
Hi, Alexandra. Thank you. Yes, I've been a cargo scientist for 21 years now, dealing with many cargo damage cases, mainly with sensitive agricultural products that can readily spoil if they're wetted. Sweat issues are simple, but they tend to be overblown and they cause a great deal of confusion. My role as a cargo scientist is to clarify and give a realistic view of both the causes and the effects of sweat.
Can you describe what you mean by sweat?
Sure. I always like to compare what is happening on ships with things we experience on a day-to-day basis. And the example here you can see on the slide is a nice cold bottle of beer. And when it's a warm summer's day, we'll often reach for a cold beer from the fridge, take it out, put it on the table, and soon enough, water droplets are forming on the side of the bottle. And this is what we know as condensation. Air holds water in the form of vapor or gas, and at any given temperature, air can only hold so much water. Lower temperature air will not be able to hold as much water vapor as air at higher temperature can. So what happens if you cool the air enough? It can no longer hold as much water as a vapor form. The water stops being a vapor, it becomes a liquid. Now, I'm sure we've all experienced this with cold drinks, not just beer. The air near the bottle is cooled and the water in the air condenses, and this is what we see on the droplets, and this often is enough to wet the table below.
So, you say that this can happen on a ship?
If you imagine the warm, humid environment is inside a ship's hold, the air is becoming warm and humid from the cargo. And instead of the bottle, the steelwork is being cooled down by the colder sea and the colder air outside the hold. So you get exactly the same effect. The water will condense on the structures that are cold enough. There's liquid condensation on the coamings, on the side platings. It's probably going to be on the underside of the hatch covers too. And the next slide just shows that. So this condensation is what we call ship sweat. Like the earlier example of the wetted table from the beer, this sweat can be problematic because it can drip down and wet the cargo.
Can this be prevented?
In some circumstances, the sweat can be prevented or lessened by ventilation, and we would recommend this is implemented by a standard ventilation regime, which we are going to be discussing shortly.
There is another type of sweat, right?
Indeed, the other type of sweat is called cargo sweat. So another homely example, I like to explain this by the open fridge example. So we always keep the fridge door closed, and that's not just because the inside will heat up if you leave it open. The most important thing is to prevent condensation inside. The food and drinks inside will get condensation on it. So a similar effect will happen on ships with a cool cargo, but a warm and humid outside conditions. So in these instances, if you keep the vents open, you're going to let warm and humid air inside the hold, and it can condense on the cargo. Cargo sweat is particularly noticeable in bagged products, and I've had it in rice shipped from North China and USA to Africa, for example. You can see condensation on the photograph we've included.
So, let me try to summarize. Cargo sweat is formed when the temperatures outside of the holds are higher than the cargo temperature inside the hold. And when that is the case, the crew should stop ventilation, right?
As simple as that, Alex.
The purpose of this video is to talk about ship's sweat, that is, the condensation that forms on the metalwork inside the ship's hold. Previously, you said that ventilation is conducted to prevent or reduce ship sweat. How do crews know when to ventilate or not?
Well, firstly, I consider masters should seek written instructions about ventilation rules from charterers. We'd recommend that the master forwards any instructions he may have received from fumigators, for example. Forward those to the charterers and ask charterers to confirm that they should comply with those rules. Now, in my experience, most charterers would respond without specific instructions, and most will expect masters are familiar with the required cargo care. So in that respect, there are two main rules that are used. There's the dew point rule and there's the 3-degree rule.
Can you explain dew point?
Yeah, remember earlier I was talking about condensation and I said that lower temperature air will not be able to hold as much water in the form of vapor as air at higher temperatures can. Dew is just an old English word for a water droplet, and dew point is defined as the temperature below which water vapor will condense into a liquid and form these droplets. Now, this can be calculated using a wet and dry thermometer you can see on the slide there. And using those temperatures and a chart or mathematical formula, you can calculate the dew point. I think many seafarers will be familiar with this procedure.
So, what is the dew point rule?
Okay, the dew point rule is to ventilate when the external air dew point is lower than the dew point inside the hold. Essentially, this replaces more humid air in the headspace of the hold with less humid air from outside. And this can help to reduce the risk of sweat in some circumstances.
Is that all the crew should do?
What's important is to carefully record the correct data and then act on it appropriately, of course.
This is an example of a cargo ventilation logbook that Brookes Bell prepared upon guard's request. Would this be appropriate?
Alex, yes, this is the sort of detail I would expect. You've got the dew point data, you've got the dates and times, the temperatures are taken, and importantly, the actions taken by the crew. So, for example, if the dew point temperature says ventilation is appropriate, but the weather or sea state is adverse and might risk ingress through vents, for example, then the crew should make the appropriate entry in the ventilation log for documenting the reasons for their action.
Before going to the other rule, the 3-degree rule, I would just like to mention that crews may not be able to safely enter the holds.
As you say, it might not be safe to enter a hold for various reasons for confined space issues, toxins, low oxygen, for example. It might actually be impossible to enter a hold because if it's full, then it's blocking the entry. You simply can't get in. Therefore, we would recommend the 3-degree rule, which I can now describe. So this requires the crew take the cargo temperatures during or at completion of loading. For this, say during breaks in loading, the crew take temperatures in 2 or 3 spots in every hatch, and on completion of loading, the temperatures should be averaged. A log should be kept of these temperatures, and you may consider just having one figure per hold, but As long as the variations between holds are small, say 2 or 3 degrees, only one average global temperature need be calculated for the entire cargo. So when a fumigation period is completed, the vents are opened only when the external dry bulb temperature is 3 degrees centigrade lower than the loaded cargo temperature. Simple as that. All this, of course, should be logged to the same degree of accuracy.
This is an example of another cargo ventilation logbook for the 3-degree rule that Guard requested Brookes Bell to prepare. It looks simpler than the dew point log, Tim.
It is simpler than the dew point log, Alex, but the same amount of detail is included or should be included. Again, you're noting the temperatures at specific dates and times, and you're noting when ventilation is appropriate. It's critical, as is giving reason why ventilation was stopped for whatever reason. For example, because we're too high in external temperature or adverse weather, etc.
I heard that many masters will not want to ventilate at night. Why do you think this is?
Well, following the rules, night temperatures usually tend to be lower than during the day. So it follows that when the conditions inside holds are conducive to sweat formation, then of course ventilation during the night time is going to be reasonable. However, because of less manning at night and with darkness, many masters will, on the basis of crew safety, hesitate to ventilate at night time. Now, we understand spell that owners will deal with ventilation on an operational basis, but we would recommend, with the assistance of a weather forecast, a master might be in a position to assess the risk of any sea or rain interfering with the ventilation during night time. And our view is, if the weather forecast provides a risk of adverse weather, then he should close his vents before the nightfall, but otherwise he can leave them open. Either way, he treats it as if it's the daytime. He should make the appropriate entry in the ventilation log for documenting his action, just like the adverse weather situations and the rain during the day.
What about the thinking that ventilation should not occur during fog?
Well, the critical factor here is the temperature of the air rather than its relative humidity. And, like I said earlier, if the conditions inside the hold are conducive to sweat formation and the external air is sufficiently cooler, then ventilation under foggy conditions is warranted. It might sound counterintuitive, but that's the science.
Thank you, Jim, for the explanation about ventilation. I would like to mention to those watching that GUARD produced a checklist for carriage of soya beans that includes your recommendations and also the templates for recording information in accordance with both the dew point rule and the 3-degree rule. Our goal is to assist the master and crew to correctly record the necessary information. This will help to defend the claims if they arise. We appreciate your time and expertise, and thanks very much for participating in the production of these videos.
My pleasure.